Hiya! It has been quite a little while since we last had a look at an optimization question. So, without any further ado, let's get started. We have the net of a right regular hexagon-based prism cut out of a rectangular cardboard. So we're given figure 1 in essence. And we know that the yellow hexagon is regular. What does that mean? So let's say we have one side, two side, three sides, 4, 5, and 6. We know the side length is A. How can we use this information? Well, we know that the total length is 30 centimeters. So that means we have h over here from a rectangle, h from a rectangle, the width of this guy, and the width of this guy. The question now becomes, how do we find an expression for this length in terms of A? And the answer is actually quite simple. If we look at the hexagon, we know that this angle here has to be 120 degrees. Why do we know this? Because the interior angle is equal to 180 degrees times the number of sides minus 2 divided by the number of sides. And this will give you 120 degrees. Furthermore, because it is an isosceles triangle, we know that this length is A and that length is also A. So finding this length is really not that hard. We can just draw the altitude in the middle. This angle will now be 60 degrees. And this tiny piece over here is going to be a sine of 60, or root 3 by 2a. Thus, the entire length is going to be root 3 of a. So we know that this length is root 3 of a, this length is root 3 of a. We can form the equation that 2 root 3 of a plus 2h is equal to 30. Or in other words, h plus a root 3 is equal to 15. So that's part A. Part B. Show that the area of the hexagonal base is 3 root 3 by 2a squared. Okay, so this part is even easier. There are way too many ways to calculate the area of hexagon. I would still choose the easiest way, which is breaking it down into triangles. So, we found out earlier that this angle here has to be 60 degrees. But this angle is also 60 degrees. That means that if we look at, say, triangle AOB, we can conclude that triangle AOB is equilateral, because angle OAB is equal to angle OBA and is equal to 60 degrees. We know the side length is equal to A, so AB is equal to OA is equal to OB is equal to A, and the area of one small triangle is going to be a half times, say, OA times OB times sine of the angle between them. And you would get 1 by 2 times a squared times root 3 by 2. Because of that, the area of the yellow base is going to be 6 small triangles. And that will give us 3 root 3 by 2 a squared. It is a 1 marker for a reason. Part C. Use differentiation to find the exact value of the maximum possible volume of the prism and prove that it is a maximum. create a box standard question. So, first part is to find the maximum volume. And volume is simply the area of the base times the height. The area of the base we found out to be 3 root 3 over 2a squared. The height is going to be h because this rectangle over here is going to be folded up to form the prism over here. And in fact, that they are nice enough to indicate that the height of the prism is h centimeters. This expression, however, has two variables. So we need to express h in terms of a. From part A, we already found out that h plus a root 3 is equal to 15. And therefore, we can express h as 15 minus a root 3. And this will give you an expression for v in terms of a only. How do we find the maximum? This one should be trivial. Differentiate v with respect to a. Set the derivative to 0. A is either equal to 0 or a is equal to this. 10 by 3 root 3. So those are the two options. How do we know which one would give us the maximum value? This is where we need to use the second derivative test. Usually, when they say show that it is indeed a maximum or a minimum, you can use the second derivative test, or you can also use the first derivative test. However, it's much harder to show the first derivative test properly because you need to obtain values to the left and to the right of the critical value that you just found. And it's not sufficient to show that this value is less than that and this value is less than that. I would highly recommend, especially when it's not too cumbersome, to use the second derivative test instead. Differentiate this a second time, and we are now down to a linear equation. Substitute a equals to 10 by 3 root 3. The second derivative will now become negative 45 root 3. And since this is less than 0, we can conclude that it is indeed a maximum. You must give the numerical answer and then clearly state that it's less than 0. For example, if you only write this less than 0 and therefore draw a conclusion, you will not get the accuracy mark for this. So be very careful with how you present your work. Moving on to part D. Find the ratio of H to A that gives this maximum volume. Okay, so this is simple. We know that H plus A root 3 is equal to 15. We also found out that A is 10 by 3 root 3. So we can literally find the numerical value of H. And thus, the ratio of h to a is 5 to 10 by 3 root 3. Or, in other words, it is 1 by 2 divided by root 3. Or you can also say it is root 3 by 2. All of these answers are accepted. Part E. Sketch the graph showing the volume of the prism as the value of A varies. Another simple one, but wait, is there a catch? So V is equal to 45 root 3 by 2 A squared minus 9 by 2 A cubed. Okay, so let's factor the 1 by 2 out. Let's factor the A squared out. We are left with 45 root 3 minus 9A. So A equals to 5 root 3 is going to be a root. Furthermore, we know that A is a side length, so A has to be positive. And because V is the volume, V also has to be positive. So effectively, the domain that we are working with is A between 0 and 5 root 3. So your curve should look something like this. It reaches the maximum at 10 by 3 root 3, the value we found earlier. The maximum volume, which I forgot to calculate, the maximum volume is going to be let me simplify this a little bit more. That's all gone. That's gone. That's gone. That's gone. So we will get 250 root 3 cubic centimeter. And this would be the end of the question. Make sure to clearly state that your curve is only valid when A is between 0 and 5 root 3 and you're all good to go.